This is the first video on section 7.6, spherical coordinates. Now, when we're looking at coordinates in R3, there are three ways to represent these coordinates. Rectangular, which we've been working with essentially from day one. Cylindrical, which we have recently learned, and now we're going to look at spherical. Now, what I'm going to do here is look at definition 225 and proposition 226 pretty much simultaneously. We're going to look at the conversions between all three coordinate systems. And so, first of all, if our rectangular coordinate is x, y, z, then we learned in a previous video, our cylindrical is r theta z, where r theta is the polar representation of the point x, y in R2. And now we're going to look at spherical. Spherical coordinates have rho, theta, phi. Rho is a distance, theta and phi are measures of angles. Now, I said rho is a distance. What distance is it? It is the distance between the point x, y, z and the origin 0, 0, 0. That means that x squared plus y squared plus z squared is equal to rho squared. So now we have this equation here, x squared plus y squared plus z squared is equal to rho squared. Also, we know that x squared plus y squared is equal to r squared. So we can write rho squared as x squared plus y squared plus z squared, or as r squared plus z squared. That's what rho is. What is theta? Well, theta is the same theta from cylindrical. And so when we're converting between coordinate systems, the z's here are the same. From rectangular to cylindrical, this z is the same as this z. They're the same. And so from cylindrical to spherical, the thetas are the same. And that's the angle that we have right here. So this is the point x, y, 0. And so we have r comes out from the origin to x, y, 0. This part here is in the xy plane. And theta right here is the angle that this segment here makes with the positive x-axis. That's what our theta is. Now, what is phi? Phi is the angle between 0 and pi that the segment joining 0, 0, 0 to our point makes with the positive z-axis. So phi is right here. So we have rho, theta, phi. Rho is the distance our point is from the origin. Theta is the same as it was for cylindrical coordinates. And phi is the angle that this segment makes with the positive z-axis. So that's what our spherical coordinate is. Now, what about some conversions? Now, in this triangle, this line here comes from the x-axis up into 3 space. So this length here is z. In my picture, z is longer than rho, but that's not to scale. Because this angle right here, so this line is in the xy plane. Now this segment here sticks up out of the xy plane and goes up. And so this is our z. This is a right triangle right here. So one leg is r, the other leg is z, the hypotenuse is rho. And so from our right triangle trigonometry, we also have r squared plus z squared is rho squared. But the reason I'm talking about this triangle is because now, if we look at this as our phi and this angle here are complementary. What that means is now, this angle here also has measure phi. And so when we look at phi in this triangle here, we can see that sine of phi is opposite over hypotenuse. So sine of phi is r divided by rho. Cosine is adjacent divided by hypotenuse. And so cosine of phi is z divided by rho. That gives us some of these equations here. Because sine of phi is r divided by rho, r is rho sine phi. Because cosine of phi is z divided by rho, z is rho cosine phi. We already know that x is r cosine theta. So x is r cosine theta, And since r is rho sine phi, that means x is rho sine phi cosine theta. We already also knew that y is r sine theta. And since r is rho sine phi, y is rho sine phi sine theta. So this gives us a way of converting through all three coordinate systems. So we take a point, we have the rectangular representation, we can find the cylindrical and the spherical. And if we have a cylindrical, we can find the rectangular and the spherical, and if we have the spherical, we can find the rectangular and the cylindrical. And so that's what we're going to do in the subsequent videos, is we're going to do conversions between the three coordinate systems.